Happy Wednesday, everybody. So today the plan is we'll just do a warm up. I'll run through the warm up with you. I already posted it, so these will be the answers, and then just catch up on either the edge elastics you haven't gotten to or the quizzes if you didn't get to that stuff yet. Otherwise, the practice one chapter test in the packet that I gave you, I put a picture of that online. It looks like this right here. And that's kind of it for today, kind of a catch-up day, and we'll pick back up tomorrow. So the warm-up, and then we're still working with scientific notation. We have our rules we talked about with scientific notation. We know when we multiply or divide, we just multiply the non-10 numbers together, and then we keep times 10 and we add the exponents together with a multiplication. Division, we do the same thing. We divide the non-10 numbers there, and then we would subtract exponents. So this guy here, find the rectangle, the area, find the rectangle's area. So we know area equals length times width. So I just do this guy times that guy. So it's 5.4 times 3.2 times 10 to the 8th times 10 to the 6th, right? I can multiply in any order, so I'm going to multiply this guy times that guy, and then this guy times that guy. And then I do 5.4 times 3.2. I know we can cheat a little bit, grab a calculator, but I'll just do it by hand. That becomes 8 and 10, put down my 0, 12, carry my 1, 15, 16, add these guys up, 8, 2, 7, 1, 1, 2 decimal places. So this gets me 17.28 times 10 to the 8 plus 6 is 14. Now I got to make sure that this guy's in scientific notation. It's not. So right now I would move this guy 14 units to the right. That's telling me. So if I move this decimal point one more unit over to the left, that means I have to add 1 to this guy. So now I have to move it 15 units over to get to that same number. And that would be the area of that rectangle in terms of scientific notation. Okay, now second problem, the area of the rectangle is given. One side measures 8 times 10 to the third. Find the missing side length. All right, so now we got to divide, right? So if I take my area, divide it by this guy here, it's going to get me the missing side. So it's 5.6 times 10 to the 10th divided by 8 times 10 to the third. So I divide these guys, 5.6 divided by 8. And then over here, I'm just going to basically subtract. I'm going to keep the 10s there. I'm going to subtract the exponents. It's top minus the bottom. That's the easy part. So 5.6 divided by 8. Again, I could grab a calculator and get this answer. 0, I believe that's 7, right? 56. So it's 0.7. So 0.7 times 10 to the 10 minus 3, which is 10 to the 7th. But once again, this guy's not in scientific notation yet. So I got to, right now, I would move it 7 units to the right. That tells me. So if I'm going to move it one unit to the right now, then I would just need to move it 6 more to get it back to that. And I really don't need that decimal point, but since I put a decimal point there, I'll put a 0 behind it. That would be the length there. If I multiply this times that, I'm going to get back to my original area there. Now with addition and subtraction, gets a little bit more challenging. We have to get our exponents have to be the same here. So I have to adjust. So what I'm going to do then is this guy, I'm going to add these. All right, so right now I have a -8, -10. So I'm going to make this guy a -8, which means right now I'd move it 6 units to the left. So to make this -8, I'd have to move it over this way 2 more units so that it would tell me to move that way 8 units. So this becomes point 1, 2, let me see here. So that becomes, 6, 4, 0. Right, I moved it over 2 places here. Now, when I move it that way, it would be 8 units. So times 10 to the -8th. This guy would stay the same, 5.9 times 10 to the -8th. And now if I go ahead and add these guys, I'm just going to add this with this, and then I'm going to have to worry about moving my decimal point around when I'm done. So 640 plus 5.9 is 645.9 times 10 to the -8th. And when you add, these guys stay the same. That's the point of putting these guys in the same spot. Okay, now I need to adjust my decimal point, which means I'm going to adjust my exponent. So I got to move it. Right now, I'd move it 8 units to the left. That's what that's telling me. So I need to move this 2 units over, 6.459 times 10. And again, since I was moving to the left and I had to move it 2 more places, so it's going to affect it by 2, it's -6. So this moved 8 units, this moved over 6 units would get me the same number. All right? Again, that's a little challenging, but that's what we're looking to do. Every time we move it, it affects this one. We just got to decide how does it affect it. And I always sort of compare it to the original. And then lastly here, if we're going to subtract, once again, I have it to the 4th and to the 5th. Let's bring this guy to the 5th power, so 7.6 times 10 to the 4th. That would be 4 units this way, which means I'd have to make this 0.76 times 10 to the 5th. Now if I move this over 1, it'd be the 4th, the same as that. Minus 8.5 times 10 to the 5th. Now just be careful with subtraction. Okay, we have our 10 to the 5th, so we know it's going to be 10 to the 5th, but it's this minus that. 0.76 minus 8.50. Well, now I subtract here, right? I basically subtract. I'm going to take the bigger number here minus a smaller number, and then it's going to be negative. So I'm going to just think of this as 8.5 minus 0.76, right, to subtract, and then my answer is going to be negative. So I'm going to have to borrow here. That becomes a 4. This is a 4 here. 14 is 7, and that would be 7. So negative 7.74 times 10 to the 5th. And this guy's already in scientific notation, so I would be done. All right, so that's the warm-up. We're probably going to end up doing a little bit more with scientific notation, then we will move on to a new topic soon, all right? All right, guys, stay well, and I'll see you tomorrow.